Welcome to this video session. I remain Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall balance redox reactions. This will be part 1 of the video. We are going to solve several problems in this video. I have some questions here on redox reactions that we are going to balance, and I will try not to skip any steps so that you can really grasp it, you can really understand it. Part 2 of the video, we shall solve more problems in the part 2. Part 1, we are going to, this video, we will solve several problems. Part 2, we shall also solve several problems. Please, before you continue with this video, it is highly recommended that you have viewed the videos on oxidation numbers part 1 and oxidation numbers part 2. Oxidation numbers part 1, oxidation numbers part 2. It is highly recommended that you have viewed those 2 videos because the knowledge will help you to really understand what we shall do in this video. The notes for this video as well as other resources can be found directly on this website, www.chemical-reaction.appspot.com. www.chemical-reaction.appspot.com. You can also go to my website, www.samuelchukwuemeka.com or www.chukwuemekasamuel.com. Any of those websites will work. We are going to start with the simple ones. We're going to start with the simple ones, and then we can later solve the more challenging ones. So we're going to first of all balance the, they give us a redox reaction. We already know it is a reduction-oxidation reaction. So they now ask us to balance it. They have given us the reaction. Now in subsequent videos we are going to deal with, if they give you only the reactants, how do you predict the products and then balance it? We are not going to do that in this video. In this video, they have given us the reactants and the products already. And we already know that that the reactions are redox reactions. So we would just balance those reactions. However, some professors will just give you the reactants and they expect you to predict the products. We shall discuss that later. And some of them would give you just the word problem. They put it in words. So reactant combined with this reactant gave, and they expect you to now do it. So we will discuss those later on. We're going to start with the simple ones. I have several questions here. In this video, we are going to deal with, they gave you the reaction, they gave you the reactants and the products, and also they might tell you that it is acidic, that this reaction occurred in acidic solution, or the reaction occurred in basic solution. We shall do some problems like that. So, but let's start with the simple ones first. Let's start with the simple ones. So I have here number 1. reaction between copper 2 ion in aqueous solution reacting with magnesium solid to give you copper, solid copper, and magnesium 2 ion in aqueous solution. So for the ones that we are going to do, for some problems we shall do, I want us to start with these simple ones. So in this one, they didn't say it occurred in acidic solution. They didn't say it occurred in basic solution. They just gave you this redox reaction. It is also an ionic reaction. And just asked you to balance it. They gave you this redox reaction and asked you to balance it. As you can see here, we didn't see oxygen. There is no oxygen here. There is no hydrogen. They just gave us the reactants and the products. There is no oxygen. There is no hydrogen. They didn't say it occurred in acidic solution. They didn't say it occurred in basic solution. So with this type of reactions, just like this, how do you balance it? So the first thing you do is, the method we are going to use in this video is what we call the half reaction method. We call it the half reaction. Half reaction method. Some textbooks will say half equation. Half equation method. So we are going to split this reaction in two halves. We're going to split it in half, okay? One half for the oxidation and the other half for the reduction. So oxidation, half reaction, and then reduction, half reaction. Now these half reactions cannot occur independently. No. Half reactions cannot occur independently. They must occur simultaneously. Okay? So we first of all find the oxidation. Let's have the oxidation, and then let's have the reduction here. Reduction. Oxidation, half reaction, and reduction, half reaction. So with the oxidation, remember what we discussed in oxidation numbers, part 2. Oxidized, okay, and reduced. When you have, yesterday if you had $5 and today you have $2, you've been reduced. Okay? And yesterday if you had $2 and today you have $5, you've been oxidized. And then we talked about the reducing agent and the oxidizing agent. We talked about those in oxidation numbers part 2. So look at that video. Today we are not concerned with the oxidizing agent and the reducing agent. Let us just write the oxidation reaction, oxidation half reaction, reduction half reaction, and then we can balance it. And once we balance those half reactions, then we balance the half reactions by itself, then we combine them. Okay? So, and then we can also check our work. So with the oxidation, you have copper 2 to solid copper, plus 2 to 0. It's been reduced. You have the copper from plus 2 to 0. So it's been reduced. And then the oxidation here, you have the magnesium from 0 to plus 2. So it's been oxidized. So it is the reducing agent. and then this has been reduced, so it is the oxidizing agent. We explained that in the oxidation numbers part 2 video. So this is the oxidation we now have here from magnesium. The oxidation half reaction is from magnesium to magnesium 2 plus. Okay? And this, of course, we say oxidation is the loss of electrons. We explained that in part 2 videos, so please look at that. So now this is 0 and this is 2 plus. So we have to balance this charge. Now this is a 0 charge here and this is charge of plus 2. So we have to balance this. So magnesium, okay, will be, we add 2 electrons here so that we can balance 2 electrons. So this is plus 2 minus 2. Electron is minus 1, but 2 electrons minus 2. I don't want you to be confused in this because actually this is loss of electrons. Actually this means that magnesium lost 2 electrons to give you the magnesium ion. The magnesium ion. So you can see it lost 2 electrons to give you the magnesium ion. So we just want this. We just want to be looking at the charges. So from here, no, we want to be looking at the charges, which is this right here. Okay, that this is 0, this is 0, and this is 2 plus 2. So for us to make this to be 0, we want to balance it right away. So for us to make this to be 0, we add 2 electrons. So 2 plus minus 2, which is 2 minus 2, which is 0. So now this is balanced. Now we get to copper. Copper is from copper 2 ion to solid copper. So this is, the charge here is plus 2, the charge here is 0. We want to balance the charges. Okay? So this is solid copper. We have to add 2 electrons to give us this copper. So now we balance this right here. We balanced it. We balance that. So we balance the oxidation half reaction and then we balance the reduction half reaction. Now we can combine both of them together. We combine the reactants together and then the products together. So what we have now is magnesium. We now combine both of them together. We now have here, we have magnesium so we have magnesium plus, now this is the reactant, this copper 2 ion plus 2 electrons to give us then the products, magnesium 2 ion plus 2 electrons plus copper. Okay? And you now cancel the electrons because you can, if this one goes here, it's minus. So you can cancel the electrons. You can now have this as this, magnesium plus copper 2. But let me show you, but subsequently, after writing it this way, you already know what I mean. But let me show you this. So this will be magnesium 2 ion plus copper plus 2 electrons. Then this comes over here, minus 2 electrons. So this goes, this out, this is out. Then you now have magnesium plus copper 2 to give you magnesium 2 ion plus copper. So this is your final answer here. So as you can see, this is balanced already. It's balanced. So as you can see, this is balanced already. So you just put in the state of the reactants and the products. So this is solid magnesium, this is aqueous, copper 2 ion, this is aqueous, magnesium 2 ion, and this is solid copper. Okay, let's do question 2. Question 2. Question 2, we have tin 2 ion aqueous combined with copper 2 ion aqueous to give you tin 4 ion aqueous plus copper 1 ion aqueous. So as you can see here, they didn't say it is an acidic solution. They didn't say it is in basic solution. There is no oxygen atom. There is no hydrogen atom. So we are good. I mean, we are starting with the simplest forms. After this, then we move into acidic solution and basic solution types. Okay? So, but I want us to begin with the simplest stuff first. Alright, so the oxidation here, we have from tin 2 to tin 4. So tin is oxidized from +2 to +4. So we have that this is tin 2 to give us tin 4. So this is a charge of +2. Let's balance this. In order to balance this, we have to add 2 electrons here. So this will be tin 2 will give us tin 4 plus 2 electrons. So because 4 minus 2 is +2. The reduction is the copper from +2 to +1. From +2 to +1 is being reduced. It is reduced. So this is from copper 2 to copper 1. So in order to balance this, we have to add just 1 electron. We have to add 1 electron to this because 2 minus 1 to give us +1. So we add 1 electron to this to give us copper 1. Alright? Some people will just write it like this, but it's 1 electron. It doesn't matter whether you remove the 1 or not. Alright, so now look at what we have now. So this is the balanced form for the oxidation half reaction. And this is the balanced form for the reduction half reaction. However, as you can see here, because this is 2 electrons and this is 1 electron, in order for it to cross out, like we have here, we have to have the same number of electrons. This is 2 electrons in the product here. This is 1 electron in the reactant. For it to cross out, because when you're crossing out, it has to be 1 on the left, 1 on the right, and then you can cross out, just like you see here, just like we did here. So what do we now do? This is like when you bring it to mathematics. elimination, when you're solving linear systems by elimination method, okay, you have to multiply this by 2. You have to multiply this by 2 to make it 2 electrons. Okay, so that eventually the 2 electrons can cancel out. So you have to multiply this by 2. You have to multiply this by 2. Okay? And when we do that, we now have that this is 2 moles of copper, 2 ion plus 2 electrons to give us 2 moles of copper 1 ion. Now this is okay. We can now combine these two folks. We can combine them now. So we now have tin 2 ion plus. Now immediately you see that, you know, you have the electrons in the one in the reactant, one in the product. They will cross out just like you see here. They're going to cross out. Okay, so we don't need to write them again. So this will be tin 2 plus 2 moles of copper 2 ion to give us tin 4, 1 mole of tin 4 ion and 2 moles of copper 1 ion. Now this is balanced. Now this is balanced. Okay? Now this is balanced. As you can see, this is, you have tin, you have copper, you have tin, you have copper. So this is 1 mole, this is 2 moles. This is 1 mole, this is 2 moles. Please, we are looking at the moles, not the charges. You use the electrons to balance the charges. Okay? You use the electrons to balance the charges. But we are looking at the moles. So 1 mole of tin 2 combining with 2 moles of copper 2 to give you 1 mole of tin 4 and 2 moles of copper 1. We write the state. This is in aqueous, this is aqueous. These are ionic reactions, aqueous. Okay? This becomes our answer. Question 3. Is it making sense, folks? Hope it is making sense. Hope it is making sense to you. Question 3. We have each one that we do, we can cross it off. Each one we do, we mark it out. We have copper 1 combining 1 mole of copper 1 ion combining with 1 mole of solid 1 mole of copper 1 ion combining with 1 mole of solid ion to give us 1 mole of solid copper and 1 mole of ion 3 ion. So you have ion 0 to ion 3. So from the ion is oxidized from 0 to plus 3. So it is the reducing agent here. So we have ion losing 3 electrons to form ion 3. So this is 0, this is plus 3. So we need to add 3 electrons here. So ion 2, ion 3 plus 3 electrons. Now this is balanced. The oxidation half reaction. This now is balanced. We move to the reduction. Copper is reduced from copper 1 to 0. copper is reduced from copper 1 to 0. So this is copper 1 to solid copper 0. So here we need to add, because this is plus 1, we need to add 1 electron. 1 minus 1 is 0. So we add 1 electron here to give us the copper. Now this is balanced here, the reduction. However, for us to combine it, this is 3 electrons here, and this is 1 electron here. So we need to multiply this. We need to multiply this by what? By 3. We need to multiply this by 3. So this gives us 3 moles of copper 1 ion plus 3 electrons to give us 3 moles of solid copper. Now we can combine both of them, and when we do that, we now have ion, 1 mole of ion combining with, reacting with 3 moles of copper 1 ion to give us 1 mole of ion 3 and 3 moles of solid copper. Okay? You put the state, this is solid, this is aqueous, this is aqueous, and this is solid state. And that's it. That's it. Okay? Alright. Let's do some more. Like I said, by the time we do a lot, it will make sense to you. By the time we do a lot. Question 4. We're still on the simple ones, okay? We're still on the simple ones. So this one is done. The next one is ion 2 aqueous reacting with cerium 4 aqueous to give us ion 3, 1 mole of ion 3 aqueous and 1 mole of cerium 3 aqueous. Cerium. So the oxidation is from ion 2 to ion 3. So ion is oxidized from +2 to +3. And we have ion 2 to ion 3. So here we need to add 1 electron. 1 electron, so 3 minus 1 is 2, to balance the charges. So this will be ion 2 gives us ion 3 plus 1 electron. This is now balanced here. Okay? The reduction is cerium. Cerium from 4 is being reduced to 3, from +4 to +3. So this is cerium, we write the half reaction, cerium 4 ion giving us cerium 3 ion. So this is the reduction half reaction. Now we balance, okay? We now balance the reduction half reaction. So we need to add 1 electron here, because 4 minus 1 is 3. So cerium 4 plus 1 electron to give us cerium 3. Now this is balanced. This now is balanced. Alright? So what's the answer? It's balanced already. It's balanced already. 1 mole of iron 2 aqueous in aqueous state combining with 1 mole of cerium 4 ion in aqueous state gives us 1 mole of iron 3 ion in aqueous state and 1 mole of cerium 3 ion in aqueous state. So it's balanced already. Okay? Una otaraya? Do you understand? Comprenez-vous? Comprendez? Alright, let's do question 5. Question 5. So, we are getting there. So, check out this. We found this one. 1, 2, 3, 4, 5, 6. Here we have chromium, 1 mole of solid chromium. Chromium combining with 1 mole of iron 2 ion to give us 1 mole of chromium 3 ion and 1 mole of solid iron. Solid iron. Okay, oxidation is chromium. Chromium is oxidized from 0 to +3. What is the oxidation half reaction? It's from chromium to chromium 3 ion. Balance it. Balance the oxidation half reaction. We have to add 3 electrons here. So this is chromium to give us chromium 3 plus 3 electrons. So this is 0. 3 minus 3 will give us 0. Because this is 3 times minus 1. And that's minus 3. Okay? Now, this is now balanced. The oxidation half reaction. The oxidation half reaction. For the reduction half reaction, we have from ion 2 to 0. Ion is reduced from +2 to 0. From +2 to 0. That means it's reduced. What is the reduction half reaction? 1 mole of iron 2 to give you 1 mole of iron. Balance it. We have to add 2 electrons here. 2 electrons. So this is iron 2 plus 2 electrons to give us iron. This is balanced. Reduction half reaction. However, this is 3 electrons right here, and this is 2 electrons here. When we combine both, remember we said the half reactions cannot occur by itself. It cannot occur independently. It must occur together. Okay? The half reactions. So, if we combine it, this is 3 electrons, this is 2 electrons. So when this goes over here, okay, when the 2 electrons crosses over to the products, we still have 1 electron left. Now we cannot have electrons in balancing redox reactions. No, we cannot have electron in the balanced form. No way. Okay, so we need to, just like we did elimination, solution of linear systems by elimination method. Some people will say elimination by addition, or elimination method you can add or subtract, it doesn't matter. But some textbooks prefer elimination by addition method. That is in solution of linear systems. If you want to cross out the electrons, okay, this is 3, this is 2. So you have to multiply this by 3 to give you 6 electrons. And you multiply this by 2 to give you 6 electrons. So they can cancel out. Okay, the electrons in the reactant and the electrons in the product will cancel out. The electrons have to be some in the reactant, and some in the product, because they have to cancel out. You can't have all of them in one, like in, here you have that. So they have to cancel out. Okay, just like we demonstrated in the first example. So we have to multiply this by 3. So it gives us 6 electrons, and then we have to multiply this by 2. By 2. We have to multiply this by 2. So when we do that here, we now have 2 moles of chromium to give us 2 moles of chromium 3 plus 6 electrons. Okay? And here we have 3 moles of ion 2 plus 6 electrons to give us 3 moles of ion. Now the electrons can cross out. Then we can combine the 2 half reactions. And when we do that, we have 2 moles of chromium, solid chromium, reacting with 3 moles of ion 2. That's the reactants. To give us 2 moles of chromium 3 ion and 3 moles of solid ion. Okay? Chromium is 2, ion is 3. As you can see here, chromium, ion. Like I said, you look at the moles, not the charges. Okay, this is 2 here, ion here is 3. Here, chromium is 2, ion here is 3. Balanced. Okay? Okay, let's do one more on this type. Then we can go to acidic solution and basic solution. So, let's do one more of this type. Then we can go to acidic solution and basic solution. Question 6. We have 1 mole of solid aluminum. Americans will say aluminum. Nigerians will say aluminium. Aluminium. What will Sam Done for Peace say? Some days I will say aluminium. Some days I will say aluminum. It don't matter, okay? You know what I'm talking about, right? You know what I'm talking about. You know what I'm talking about. You feel me, bro? You feel me, bro? You feel Hey! You feel me, bro? You know what I'm talking about, bro? You know what I'm talking about. You feel me, bro? Okay, so 1 mole of aluminum reacting with 2 moles of hydrogen ion to give us 1 mole of aluminum 3 ion and 1 mole of hydrogen gas. So this is aqueous, this is aqueous. So 1 mole of aluminum solid aluminum reacting with 2 moles of hydrogen ion to give us 1 mole of aluminum 3 ion and 1 mole of hydrogen gas. Alright, I know with this now, okay, they did not say acidic solution. They did not say basic solution. I know some of you will say, well, it's acid, so because you have hydrogen ion. You're very correct if you say that. However, as you can see here, we don't have water, like we don't have any oxygen. we didn't see oxygen. So let us not, if you don't see oxygen, if they did not say acidic solution, if they did not say basic solution, please don't try to put something you don't see. Okay? Don't try to come and start putting oxygen. No. Just, you saw aluminum, you saw hydrogen. In the reactants, you saw aluminum, you saw hydrogen. In the products, do it that way. Do it that way. Don't try to add something else. Alright, so from here we have 0 to +3. Aluminum is oxidized from 0 to +3. So this is aluminum to aluminum 3 ion. And this gives us aluminum 3. We have to add 3 electrons. Here, this is balanced here. This is balanced here. Right? It's balanced there. Now for the reduction, hydrogen is reduced from +1 to 0. Okay? The oxidation number of an element in free state is 0. Okay? So we now have 2 moles of hydrogen ion giving us 1 mole of hydrogen gas. Now the charge here is +2. The charge right here is +2. If it's just this, then it is +1, the charge. But this is +2. So to balance this, because this is 0, okay? Now, be careful here, because this is, I know the oxidation number is +1, I know. But the charge here that they gave us is +2. So you have to add 2 electrons, so you can make this 0. Because 2 minus 2 is 0. 2 plus minus 2 is 2 minus 2, which is 0. So this is 2 moles of hydrogen ion plus 2 electrons to give us 1 mole of hydrogen gas. Now this is balanced right here. Right? Well, as you can see, this is 3 electrons here, and this is 2 electrons here. So we have to, this is in the products, this is in the reactants, which is okay, which is the right thing. Okay. Electron will be in the product, and electron will be in the reactant. Like I said, it will not be in either only reactant and only product. No, it has to be both ways, so it can cross out. So you multiply this by 3, you multiply it by 3, and that gives us 6 moles of hydrogen ion plus 6 electrons to give us 3 moles of hydrogen gas. Right? And you multiply this by 2. You multiply this by 2. So you have 2 moles of aluminum reacting to give 2 moles of aluminum 3 plus 6 electrons. Now you can combine them. Now you can combine them and check your work. So we now have 2 moles of aluminum reacting with solid aluminum, reacting with 6 moles of hydrogen ion aqueous to give us 2 moles of aluminum 3 ion aqueous and 3 moles of hydrogen gas. Alright, can we check to see whether it is balanced? Yes, we can. So, aluminum, hydrogen, aluminum, hydrogen. So, this is 2 moles, this is 6 moles. Here, this is 2 moles, And of course, this is 3 moles of hydrogen gas, of course, which is 6 moles of hydrogen. 3 times 2 is 6. Okay? Balanced. Alright? Okay, folks. Let us now start. We have done at least these ones. You have at least the basic idea. You have the idea of how this works. When they did not tell you acidic solution, when they did not say basic solution, when you don't see hydrogen or oxygen, like you saw, the elements you see in the reactants are just the elements you see in the products. They didn't write acidic solution, they didn't write basic solution. You just do it the way we just did. Those are the simplest forms. Now let's go to this. Question 7. Acidic solution. When we have a reaction in acidic solution, how do we balance it? When we have a reaction in basic solution, how do we balance it? So I have several problems here. We're going to do one acidic, one basic. One acidic, one basic. We just keep doing it that way. How about it? Right? How about it? Let's just do it that way until we get tired in this video. How about it? Okay, so question 7 I have here. Heptaoxodichromate 6 ion, aqueous. Reacting with, now we have done in the videos oxidation numbers part 1 and part 2. We have found this, we name it. So I will just be saying the names, and if you understood those 2 videos, you should understand what I'm saying when I'm naming it. So when I name this now, heptaoxodichromate 6 ion, don't panic. How did he know these names? Please, if you ask that question, how is this heptaoxodichromate 6 ion? If you just ask that question, that means you have not viewed those 2 videos. It's very important, importante, es importante that you view those 2 videos. Es importante. Okay? So 1 mole of heptaoxodichromate 6 ion reacting with this is dioxonitrate 3 ion. Dioxonitrate 3 ion, 1 plus x minus 4. Yes, 1 minus 4. Yeah, 1 plus x minus 4. So dioxonitrate 3 ion, to give you chromium 3 ion, aqueous, and trioxonitrate 5 ion. And this is in acidic solution. In acidic solution. Now, some of you might say, how do I know, like, what if they didn't give me this in acidic solution? Alright, no problem. You watch the subsequent videos whereby they didn't say whether it is acidic or whether it's basic. Watch the subsequent videos, we shall treat that. However, if you really want to know right away, then you have to view videos on acids, bases, and salts, so you can know that. Okay? Otherwise, you just have to wait. So they gave us this. We have to balance this, and this is in acidic solution. Let me make sure I wrote this well. Okay? Yes, I did. Now, you want to, you can write down the steps I will dictate, I'm not going to write those steps down in this video because it will already be written here. Okay, I have already written them in this website, the steps to balance this. So I will not write the steps down, but if you want to take down, that's fine. However, it will be good if you pay attention, and you can go to that website and read the steps as well. But if you want to take down, that's fine. Just you have to listen properly. When they give you this to balance, the first thing you want to do first is write the oxidation half reaction and the reduction half reaction. Let's do that. So this is chromate 6, heptaoxo dichromate 6, from 6 to 3. From 6 to 3, that's reduced. So chromium is reduced from +6 to +3. Okay? Chromium is reduced from +6 to +3. Now pay attention, please. Don't look at my cat. Yeah, okay. So from +6 to +3. Okay, it's reduced. Heptaoxo dichromate 6 to chromium 3 is reduced. Now, the nitrogen is the thing that is oxidized. Here, this is dioxonitrate 3, and this is trioxonitrate 5. So this is from, nitrogen is oxidized from +3 to +5. Okay, you write the oxidation half reaction. Okay, we write it. Dioxonitrate 3 to trioxonitrate 5. We will write the reduction. Let us just deal with oxidation. Anything I'm doing, please follow me. Anything I'm doing now, please follow me. So you write, let's finish with oxidation, then we go to reduction, half reaction. The next, first of all, I wrote oxidation, half reaction. Then the next step is to balance the oxidation half reaction. Balance everything besides oxygen and hydrogen. Okay, I repeat, balance everything, every element besides oxygen and hydrogen. See that? So this already is balanced. If you look at it, because the nitrogen is balanced. Nitrogen is 1 mole in the reactant, and this is 1 mole in the product. Let's look at the reduction. We do chromium heptaoxo dichromate 6 to chromium 3. Chromium 3. Okay. Balance everything besides hydrogen and oxygen. So let me write this here. That it is. Let me write this again to tell you it's balanced. It is balanced just for the elements. Balance every element besides hydrogen and oxygen. Okay. Balance every element besides hydrogen and oxygen. This is balanced. Here, balance every element besides hydrogen and oxygen. Okay, well, the elements we see here in the reactant is chromium and oxygen. And here we don't see hydrogen, we don't even see oxygen. That's fine. However, this is 2 chromium. This is 2 moles of, these 2 atoms of chromium. Okay? And this is 1 mole of chromium 3. So we have to put, and like I said, balance every element besides hydrogen and oxygen. So this is 2 atoms of chromium. I gotta put 2 here. So I come here, I write this, and this was 2 chromium 3. Yes. 2 moles of chromium 3. So this chromium now is 2, and this chromium now is 2. It's not charges. Leave the charge. Okay? Alright? Now, after you've balanced, number 1 is write the oxidation half reaction and the reduction half reaction. Step 1, write the oxidation half reaction. Step 2, write the reduction half reaction. Step 3, in the oxidation half reaction, balance everything besides hydrogen and oxygen. Balance every element. Nitrogen is 1, nitrogen is 1. Here in the reduction, balance every element besides oxygen and hydrogen. See that? But here chromium is 2. So we gotta put 2 here for chromium. Okay, step by step. Okay. Excuse me. Then the next thing is balance oxygen. We want to balance oxygen first. Balance oxygen first. Let's come back to oxidation. Whatever we do in oxidation half reaction, we shall also do in reduction half reaction. So oxidation half reaction, balance oxygen atoms by what? Oxygen is something you balance first. I didn't say hydrogen. I said oxygen. I did not say hydrogen. Balance oxygen by doing what? Now, if you don't see oxygen, then don't add it. Like I said, whatever you don't see, don't add. Well, whatever you don't see, don't try to add. Okay? Just calm down. Calm down. Camantes, Montes. Camantes, Montes. Camantes, Montes. Okay? Wait will be. Dajua. So, in balancing oxygen, balance oxygen atoms. Next. For the one that has the lesser oxygen, add water. Add water. Okay. Look at this here, the reactant. Oxygen has 2 atoms. In the product here, this is oxidation half reaction. In the reactant, oxygen has 2 atoms. In the product, oxygen has 3 atoms. 1 atom of nitrogen, 3 atoms of oxygen. We are going to add 1 water molecule to the reactant here. So because we're adding 1, because this is 3, we want to add 1 water to make it 3 oxygen atoms. Okay? Now, assuming this was 4, then we're not going to add, and this was 2, we will add 2 water molecules. Does it make sense? Because we want to balance oxygen. So, I'll come here, I put this plus 1 water molecule to give me this. See that? To give me this. Does it make sense? So oxygen is balanced now. Nitrogen is balanced, oxygen is balanced. See it? Here we come to the reduction. Whatever you do in the oxidation, please do a reduction. These are 7 oxygen atoms. 7. So I have to add 7 water molecules here. Okay? So this will be heptaoxodichromate 6 ion. I will not add water here, no. Okay? Because this has, and this doesn't have any oxygen. So this is 2 moles of chromium 3 ion plus 7 molecules of water. Oxygen is balanced. Oxygen is balanced. Okay? The next thing is balance hydrogen. Remember I said balance all elements besides oxygen and hydrogen. Then balance oxygen. Then balance hydrogen. Okay. Now, you look at this here in the reactant, we have 3 moles of hydrogen. Hydrogen in this one, dioxynitrate 3 acid. Okay, dioxynitrate 3 is one mole plus 2 atoms of hydrogen here. Okay, so 1 mole of hydrogen gas or 2 atoms of hydrogen. That's 3 atoms of hydrogen. 3 atoms of hydrogen. But here it doesn't have any. So we balance hydrogen by putting hydrogen ions. You know, some textbooks will say proton because a proton is positively charged. Plus 1. So hydrogen ion plus 1. So some textbooks will just say proton. That's fine. So I'm gonna come here. Dioxynitrate 3 combining with 1 molecule of water to give us trioxynitrate 5 plus 3 moles of hydrogen ion. See that? You see that? Here, hydrogen is not here at all. But here, hydrogen is 14. 14, 2 times 7 is 14. So we have to add 14 moles of hydrogen here. So this will give us chromium heptaoxodichromate 6 ion, the dichromate 6 ion, plus 14 moles of hydrogen to give us 2 moles of chromium plus 7 moles of water. As you can see here, if you look at the oxidation half reaction, nitrogen is balanced, 1, 1. Oxygen is balanced, 3, 3. Hydrogen is balanced, 3, 3. See that? In the reduction half reaction, chromium is balanced, 2, 2. Oxygen is balanced, 7, 7. Hydrogen is balanced, 14, 14. So we balanced all the elements. Then you now balance the charges. Okay? By adding electrons. After you balance the elements, you balance all elements besides oxygen and hydrogen. Then you balance oxygen. Then you balance hydrogen. Then you balance the charges by adding electrons. Alright, I'm gonna let me come here and write because of space. Let me come here and write oxidation. So as you can see here, the charge on the left hand side is 0. 0 plus 0, that's 0. On the right hand side we have minus 1 plus 3. Because 3 times plus is 3 plus 3. 3 times 1 is 3. 3, the charge, 3 minus 1 is 2. Is 2. So then this is 0. Okay, let me write it down here. So you have dioxynitrate 3 plus water to give us trioxynitrate 5 plus 3. So here, this is minus 1, and this is plus 3. Because 3 times 1 is plus 3. So minus 1 plus 3 is 2. Is 2. This is 0. This is 0. So for us to balance this, we have to add 2 electrons there. We have to add 2 electrons. So 2 minus 2 is 0. So this will be dioxynitrate 3 plus water, 1 mole of water, to give us trioxynitrate 5 plus 3 moles of hydrogen ion plus 2 electrons. Plus 2 electrons. This is not the final answer. This is not the final answer. No way. No, not the final answer at all. No. This is the balanced oxidation half reaction. Okay? Because 2 minus 2 is 0. So balanced oxidation half reaction. Now we come to reduction. Reduction half reaction. Reduction half reaction. So we have here dichromate 6 ion plus 14 moles of hydrogen to give us 2 moles of chromium 3 and 7 moles of water. Okay, this is minus 2 here. This is plus 14. As you can see, this is minus 2. And this 14 times 1 plus 14. Minus 2 plus 14 is plus 12. Plus 12. Okay? That's plus 12. For the reactants, here. Here, this is plus 3. And this is 0. So this is plus 3. Sorry. I'm so sorry. I am so sorry. This is 2 times plus 3 is plus 6. This is plus 6. Plus 6. Okay? Please, you have to be careful. Yeah, because this is 2 times plus 3, which is plus 6. So you have plus 12, you have plus 6. This tells you you have to add 6 electrons. Because 12 minus 6 is 6. So you add 6 electrons here. Add 6 electrons here. So we have heptaoxodichromate 6 ion plus 14 moles of hydrogen ion plus 6 electrons to give us 2 moles of chromium 3 ion plus 7 moles of water. Okay? Now this is the balanced reduction half reaction. Alright. So we see 6 electrons here in the reactant. We see 2 electrons here in the product. Like we said, you have to see electrons in the reactant and electrons in the product. It has to be that way. It cannot be one-sided. Okay, good. So we now have to multiply this by 3. So we can make these 6 electrons, so it will cross out. The electrons will cancel out. Alright, we have to multiply this by 3. So we have to multiply this by 3. So the electrons will cancel out. Okay? So what I'm going to do now is, I'm gonna, you can take this down. I'll come back here. I'll come back here and because I want to show you everything. I want to show you all work. I want to show you all work so you can see the final answer. So we multiply that by 3 for the oxidation. Alright? So this is still for the oxidation. This is 6 already for the reduction, so no problem. We just multiply that by 3. We now have 3 moles of dioxynitrate 3 plus 3 moles of water to give us 3 moles of trioxynitrate 5 ion plus 9 moles of hydrogen ion. Okay, 3 times 3 is 9. Plus 6 electrons. Okay, so we now know 6 electrons in the reactants, 6 electrons in the product, they will cross out. We know that. We know that. Alright folks, now this is what we now want to do. We now want to combine. We have balanced this. We've made sure that they are now 6 electrons so we can cross them out. Let us now combine them together and then reduce, and then we can trim out further. Okay, so Let's combine everybody. So I'm going to write this in order. I'm going to write it in order so you know, we're looking, let's write the reactants first. So this will be 3 moles of dioxynitrate 3 plus, I will still write 3 moles of water, I will, okay? But let me write this first. 1 mole of chromium, heptaoxodichromate 6, plus 14 moles of hydrogen plus 3 moles of water. Okay, these are our reactants. These are reactants. Okay, some of you might ask me, why didn't I just write this first and then write that? It doesn't matter. It does not matter. I just want to be, you know, I don't want water and hydrogen ion to mess up. I don't want it to mess up. I want to show you something. Okay? So I want to write the reactants as is first. I want to write, this came first, but it doesn't matter. Okay? So now the products. This is 3 moles of trioxynitrate 5 plus 2 moles of chromium 3 ion plus 9 moles of hydrogen ion plus 7 moles of water. Okay. I don't want to, you know, as you can see here, I have hydrogen ion and water on the left hand side. I have hydrogen ion and water on the right hand side. I don't want that. So we're going to transfer. We will not have minus. We're not going to have minus. So wherever is bigger, you know, the bigger will transfer the rest. So we can still have positive. Like this is 9 moles of hydrogen ion is going to go to the left. And then this 3, because it's smaller, because we want 14 minus 9 to give us 5. And then 3 moles of water will have to go to the right because it's smaller. So the bigger guy stays. The bigger guy stays where he is, in the hydrogen ion and water molecule. The bigger guy stays. The smaller guy moves. So we, you know, just like we solve equations in mathematics. Okay, when you have 14x and then you have here 9x, you know, imagine when you have maybe 14x 5 plus 14x and you have 3 plus 9x. You're not going to make this guy to come over here. You're going to use this guy that goes. Okay, 9x goes here, 14x minus 9x. So just that idea. So we now have here, please, I know why I'm explaining this, so you say, and it will make a lot of sense to you, okay? This is now 3 moles dioxynitrate 3 plus, you see why I didn't want to keep on, I want this to come first. So this is plus 14 moles of hydrogen minus 9 moles of hydrogen, okay? Because this 9 comes here, is minus. And then this 3 will go there. So this gives us 3 moles of trioxynitrate 5 plus 2 moles of chromium 3 ion plus 7 moles of water minus 3 moles of water. Now we can now write the balanced redox reaction. So this gives us 3 moles of dioxynitrate 3 aqueous, put the state, plus 1 mole of heptaoxodichromate 6 aqueous, plus 5 moles of hydrogen ion aqueous, to give us 3 moles of trioxynitrate 5 ion aqueous plus 2 moles of chromium 3 ion aqueous plus 4 moles of water. Liquid water. Liquid water. This is now your balanced reaction. This. Okay, folks. Please, I want to give you a good advice. A good advice. After writing this, please check it again. Check again. Now, with acidic, with the steps I gave you, this is for acidic solution. With basic, which we're going to do next, we're going to do the same thing, but we will do more. Okay, I'm going to explain what we do more. Like I said, we do acidic, we do basic. Basic solution involves just some extra steps. Okay? But then, folks, after writing this, remember what we did. Okay? After writing this is now our answer. Check it. Let's check it. Okay? Let's check it. So, let's check it to make sure that everything is balanced. Let's check it. So in the left hand side we have hydrogen, we have nitrogen, we have oxygen, we have chromium. Okay? Right hand side the same thing now. Hydrogen, nitrogen, oxygen, chromium. Okay, left hand side, hydrogen, we have 3 moles. 3. We have 3 here. 3. Then plus 5. 3 plus 5 is what? 8. 8. Let's check the products. Here, no hydrogen. Here, no hydrogen. Here, 4 times 2. 4 times 2, 8. You see? Good. Thank God. Thank you, Jesus Christ. Hydrogen is balanced. Okay. Now let's do the nitrogen. Nitrogen. Here we have 3. We have 3 moles here, right? Nitrogen. So this is 3. And nitrogen here is 3. Good. Oxygen. We have 6. 3 times 2. See, this 3 times 2, 6 for oxygen, 6. Here we have 7. 7. 6 plus 7. So 6 plus 7. 6 plus 7. Okay? And that gives us 13. Oxygen here, we have 9. 9 plus 4. And that gives us 13. See that? Chromium. Chromium, we have 2. We have 2. And then chromium here, we have 2. Thank God, thank God, thank God, thank God, thank God, thank God. So that is it, folks. That's it. Acidic solution. Okay. And don't worry, we are going to, I brought questions. Okay. The thing is, we'll have to do part 2, but I took my time to kind of explain this well. Right? Did I do it well? All right. And question 8. We're going to do question 8, basic solution. Let's do that in basic solution. Like I said, let's do 1 acidic, 1 basic. 1 acidic, 1 basic. Okay. Question 8. Oh sure. Question 8. We have 1 mole of silver combined with 1 mole of zinc 2 aqueous to give 1 mole of silver oxide aqueous and 1 mole of solid zinc aqueous. And this is in basic solution. And this is in basic solution. In basic solution. All right. First step, split it into oxidation and reduction, half reactions. So I'm going to come here, I write oxidation. Oxidation is from, of course, zinc 2 to zinc is reduction, is reduced. So oxidation is from silver. Silver is from 0 to, here this is 2x. 2x minus 2 equal to 0. So 2x is equal to 2. X is equal to 1. So this is plus 1. Okay? So that's silver is oxidized. It is the reducing agent. Then the oxidation half reaction is from silver to silver oxide. Silver oxide. Okay? Reduction is from zinc. Zinc is reduced from plus 2 to 0, right? From plus 2 to 0. So the reduction half reaction is from zinc to ion to zinc in the free state, solid zinc. All right. Next step. Balance all elements besides oxygen and hydrogen. Now, in basic solution, the same steps we did in acidic solution, we shall do it first. Then we shall do extra. Okay? Then we shall do extra. Okay? We're going to balance all elements besides oxygen and hydrogen. Okay? In the oxidation half reaction, silver on the left hand is 1 mole of silver. Silver on the right hand is 2 atoms of silver. Alright? So we're going to put 2 here on the left. So 2 atoms of silver to give us this. Okay? Here, in the reduction half reaction, zinc is the same, 1 mole of zinc to 1 mole of zinc. So this is just zinc 2 to zinc. Okay? Then, we get back to oxidation, and like I said, whatever you do in oxidation, you do in reduction. If it's applicable. In the oxidation, we don't have any oxygen atom on the left. We don't. In the reactant. In the product, we have 1 oxygen atom. So we need to add 1 water. In the reactant, we add 1 water molecule to balance the oxygen here. So this is 2 moles of zinc plus 1 molecule of water to give us this. Okay, oxygen is, now as you can see here, silver is balanced, oxygen is balanced. In the reduction, did you see oxygen? No. Please don't add it. Please don't add any water. No. If you don't see it, don't add it. Don't try to put something, don't try to start something. Don't try to start something. No. Okay? Don't try to start something. So we don't see, we leave it. We leave it, it's balanced. Don't add water, don't add oxygen, don't add hydrogen. It's none of your problems. You don't see oxygen, you don't see hydrogen, leave it. Now we come back to this oxidation half reaction. Hydrogen is now two atoms of hydrogen, one molecule of hydrogen, which is 2 atoms, okay, of hydrogen in the reactant. So we need to add 2 moles of hydrogen ion in the product. So we can balance hydrogen. So this is 2 moles of silver plus 1 mole of water to give 1 mole of silver oxide plus 2 moles of hydrogen ion. Now silver is balanced, hydrogen is balanced, the silver is balanced, oxygen is balanced, hydrogen is balanced. In the reduction, it is balanced. Then we now balance the charges. In oxidation, we have 2 moles of silver, 1 mole of water, to give 1 mole of silver oxide, plus 2 moles of hydrogen ion. The charges, this is 0, this is 0, this is 0, and this is plus 2. So we need to add 2 electrons on the right hand side in the products. We add 2 electrons. So this is 2 moles of silver plus 1 mole of water to give us 1 mole of silver oxide plus 2 moles of hydrogen ion plus 2 electrons. Now this is the balanced oxidation half reaction. This is the balanced oxidation half reaction. Okay? Now we do the reduction. Reduction half reaction. The reduction half reaction. So we have zinc 2 ion to give us zinc. We add 2 electrons here. 2 electrons. Because this is plus 2, as you can see here, this is plus 2, and this is 0. Excuse me. So you add 2 electrons to give you 0 here. This here is balanced. The reduction half reaction. Balanced. Alright. We know the 2 will cross out to 2 electrons will cross out. 2 electrons here in the product, 2 electrons in the reactant. It's going to cross out. Okay? Now let's join both half reactions. Let's join them together. Okay? We join them together. So, I will join the main ones first, like, before I write the water. So this is 2 moles of silver plus 1 mole of zinc 2 ion plus 1 mole of water to give 1 mole of silver oxide plus 1 mole of zinc plus 2 moles of hydrogen ion. Okay, the electrons is out. Because this is 2 electrons, this 2 electrons, so that's gone. 2 electrons in the products, 2 electrons in the reactants. That's gone. Alright, we now come here. When you have done this, look at this, folks. So, this is, if this was an acidic solution, we are done. Because it's balanced. If this was an acidic solution right now, if this was an acidic solution, it's balanced. However, this is basic solution. So take down the extra steps. With the basic solution, after you've done all this, like you've balanced all elements besides oxygen and hydrogen, you've written out the oxidation half reaction, reduction half reaction, you've balanced all elements in both half reactions besides oxygen and hydrogen. You've balanced oxygen in both half reactions as applicable. You've balanced hydrogen in both half reactions. You've balanced this as applicable. You've balanced the charges in both half reactions. You've made sure the electrons are the same in both half reactions. You combine them. Okay. In basic solution, you add this step also. For this hydrogen ion, okay, you add hydroxide ion. You add hydroxide ion. How many do you add? As many hydrogen ions as you see. You add hydroxide ion. And whatever you do on the right, you do on the left. Sometimes hydroxide ion sometimes hydrogen ion might also be here. Okay, in the reactant. So wherever it is, wherever you see the hydrogen ion, add as many hydroxide ions on both sides. Okay, in both the reactants and in the products. So we have 2 moles of hydrogen ion here. So we're going to add 2 moles of hydroxide ions to both sides, to both the product and the reactants. Okay, because we have 2 here. So we do that because this is basic solution. So if it was acidic solution, this is it. But basic solution, you have to, wherever you see the hydrogen ions, as many hydrogen ions as you see, add the same number of hydroxide ions to both the reactants and the products. So this will be 2 moles of silver plus 1 mole of zinc 2 plus 1 mole of water plus 2 moles of hydroxide ion to give us 1 mole of silver oxide plus 1 mole of zinc plus 2 moles of hydrogen ion plus 2 moles of hydroxide ion. Some people will ask me why. Okay, and it's base, hydroxides are strong bases. When you view acids, bases, and salts, and it will make more sense to you. Okay, videos on acids, bases, and salts, then it will make more sense to you. Now, we add this here so we can have 2 water molecules. That's why we have it here. So we go ahead, we have this 2 moles of silver plus 1 mole of zinc 2 plus 1 mole of water plus 2 moles of hydroxide ion to give us 1 mole of silver oxide plus 1 mole of zinc plus 2 moles of water. 2 moles of water. You see that? 2 moles of water. Then, remember, you now have water in the reactant, water in the product. So this guy is the bigger guy, so this guy will have to move. Okay, this guy will have to move. So we have 2 moles of silver plus 1 mole of zinc, 2 plus 2 moles of hydroxide ion to give you 1 mole of silver oxide plus 1 mole of zinc plus 2 moles of water minus this water. Minus this water. Okay? So the final answer you have now is 2 moles of silver plus 1 mole of zinc plus 2 moles of the hydroxide ion to give us 1 mole of silver oxide plus 1 mole of zinc plus 1 mole of water. And this is our final answer. Now, please, por favor, do not stop here, no. We have to do what's check. Let us check our work. Let us check our work. It's good after writing this to make sure you check it to make sure that everything is balanced. So left hand side we have silver, we have zinc, and we have oxygen, and we have hydrogen. Here, right hand side the same thing. Silver, zinc, oxygen, hydrogen. Silver here is 2. Silver here is 2, balanced, thank God. Zinc here is 1. Is zinc 2 ion, but it's 1 mole, okay? 1, the mole is what you should be checking. Zinc here is 1 mole of solid zinc. Please put the state of the reactants and products. This is solid silver, this is aqueous, this is aqueous, this is solid, right? Aqueous, I'm sorry. Aqueous, silver oxide. This is solid zinc, and this is liquid water. Liquid water. All right. Oxygen is 2 here. 2 on the left, 2. And here is 1 plus 1, 2. Thank God it's balanced. Hydrogen is 2 in the reactants, and in the products it is 2. Yeah. Gracias el Señor. Gracias el Señor. Gracias el Señor. Otito diri Chineke nna n'elu kashenyo. Otito diri Chineke nna n'elu kashenyo. Otito diri Chineke nna. Ekele diri Chukwu. Otito diri Chukwu. Ekele diri Chineke. Ekele diri Chukwu. You know, my name is Chukwu Emeka. As people say, Chukwu Emeka. Chukwu Emeka, you know what it means? It means God has done a lot for me. Chukwu means God. Yeah. In Igbo language, Chukwu is God. Chineke is God our creator. Chukwu, Chi-ukwu, big God, mighty God. Chineke is God who creates, God our creator. So Chukwu Emeka means God has done a lot. Emeka means has done a lot. Okay. All right. So this is how we do basic solution. We're gonna do the same steps for acidic. You just have to add that extra step of hydroxide ions. And please, you make sure you check it. All right. So let's do question 9. Question 9. Question 9. Let's do acidic solution. Acidic solution. Here we have, can you name this? Can you name this? Tetraoxo manganate 7 ion. We did this. Okay, we did this in those 2 videos. You will see this. Then plus the chloride ion, aqueous. This is acidic solution. To give us manganese 2 ion aqueous, and what we call this is hypochlorous acid, which is monooxochlorate 1 acid. Oxochlorate 1 acid, you know, whether you say monooxo, 1 oxygen. So oxochlorate 1 acid, which is your hypochlorous acid. Hypochlorous acid is the old name, and the IUPAC name is oxochlorate 1, because this is 1 plus x minus 2 equal to 0. So x minus 1 equal to 0, so x is 1. So chlorate 1, okay? Chlorate 1. The oxidation number of chlorine there is +1. Okay, like this. So that's your oxochlorate 1 acid, monooxochlorate 1 acid, which is your hypochlorous acid. Old name is hypochlorous acid. This is an acidic solution. Okay, folks, let's get this done. As usual, we want to write the half reactions. Oxidation, half reaction, and reduction, half reaction. So we have here oxidation, reduction. So manganese 7 to manganese 2, that's reduction, okay? Tetraoxomanganese 7 to manganese 2, that is reduction. So manganese is reduced. Please, if you don't understand what I just did now, please go and watch those 2 videos, okay? Manganese 7 to manganese 2 is reduced. Now oxidized is the chlorine. Chlorine is oxidized from -1 to +1. Okay, because this is -1 and then this is oxochlorate 1 acid. So the half reaction for this is chloride ion to oxochlorate 1 acid. It is a hypochlorous acid, old name. Alright. And then this one is from tetraoxomanganate 7 ion to manganese 2 ion. Manganese 2 ion. Alright. The next thing we have to do, folks, we have to balance all elements besides oxygen and hydrogen. So that is chlorine. Chlorine is 1 here, chlorine is 1 here. So we're good. So let's write it again, it doesn't matter. So this is already balanced. Like for the chlorine. So here, manganese is 1 here, manganese is 1 here. Okay, not the charges, no. So manganese is 1 here, manganese is 1 here. So manganese is balanced. Manganese is balanced. Okay? It is balanced. Right? Then let's balance oxygen. Here in the oxidation, we have to add 1 water molecule. 1 water. Because the product is 1 oxygen atom. The product is 1 oxygen atom. So we add 1 water molecule. So this is 1 mole of water, or 1 water molecule. Chlorine plus water to give oxochlorate 1 acid. So chlorine is balanced, oxygen is balanced. Here, this is 4 oxygen atoms. So we add 4 moles of water, or 4 molecules of water here. So we have manganese 7 to give us manganese 2 plus 4 molecules of water. Okay? 4 molecules of water. So manganese is balanced, oxygen is balanced. Now we balance hydrogen. Here on the left, in the reactants, for the oxidation half reaction, in the reactants, we have 2 atoms of hydrogen. So we have to add 2 moles of hydrogen ion. We balance hydrogen by adding hydrogen ions. We balance oxygen by adding water. Does it make sense? Yeah. We balance oxygen by adding water molecules. And we balance hydrogen by adding hydrogen ions. Some cases we might add hydrogen ions, but let's not go into that for now. For now, we are balancing with hydrogen ions. Okay? So we'll put, did I say 2 moles of hydrogen? No. It's not going to be 2 moles. You know why? Yeah, okay. So hydrogen is 2 atoms here. But hydrogen is 1 atom here. So we just need to add 1 more. 1 more hydrogen ion here. So to make it 2. Does it make sense? Okay? Does it make sense, folks? So this will be chloride ion plus water to give us oxochlorate 1 acid plus just 1 hydrogen ion. Yeah? Alright? And here, we don't even have any hydrogen here in the reactant. But we do have 8 hydrogen atoms, 4 moles of hydrogen gas. You can say that, which is 8 hydrogen atoms. 8 hydrogen atoms here. So we add 8 moles of hydrogen ions here. So this will be tetraoxomanganate 7 ion plus 8 moles of hydrogen ion to give us manganese 2 ion plus 4 moles of water. Does that make sense? See that? So all the elements are balanced. Right? All of them are balanced. The next thing we have to do now, balance the charges. Balance the charges. Alright, so we write oxidation, and let's write it out. Chloride ion plus water to give us oxochlorate 1 plus hydrogen ion. So the charge here is -1, the charge here is 0, the charge here is 0, the charge here is +1. Right? So we need to add, for us to have -1, if we add only 1 electron, it will give us 0. So we have to add 2 electrons. So it will give us -1. Because -1 plus 0 is -1. -1 plus 0 is -1. So we need to add 2 electrons. So it will be -2. And then you have 0 plus 1 plus -2. And that gives you 0 plus 1 minus 2, which is -1. Okay? So we have the chloride ion plus water to give us oxochlorate 1 acid plus hydrogen ion plus 2 electrons. So this is balanced now. Balanced oxidation half reaction. That's it. Okay? Now let's do the reduction. Reduction half reaction. We have tetraoxomanganate 7 plus 8 moles of hydrogen ion to give manganese 2 ion plus 4 moles of water. Let's write the charges. Overall charge here is -1. Here is +8. Because 8 times +1 is 8. -1 plus 8 is +7. +7. Here is +2, and this is 0. So this is +2. So what do we need to do? We need to add 5 electrons in the reactant so we can have +2. We need to have 5 electrons. 5 electrons in the reactants. So 7 minus 5 is +2. Okay? So we have manganate 7 ion plus 8 moles of hydrogen ion plus 5 electrons to give us manganese 2 ion plus 4 moles of water. This is the balanced reduction half reaction. All right. Now we have to balance the electrons. We have to balance the electrons. This is, of course, the electrons here are in the products and the electrons here are in the reactants, which is great. That is what we want. Electrons in the product, electrons in the reactant. Okay, so, this reduction, gain of electrons, and this is oxidation, loss of electrons, because this is actually minus 2 electrons, like I showed you. The oxidation is loss of electrons, reduction is gain of electrons. So we have to balance the electrons. We multiply this by 5. We have to multiply this by 5. And we multiply this by 2. We multiply this by 2. So we can balance it. So we will cancel it. Okay? So we come here. So we have our oxidation. We have our oxidation. We have 5 moles of chloride ion plus 5 moles of water to give us 5 moles of oxochlorate 1 acid plus 5 moles of hydrogen ion plus 10 electrons. The reduction, we have 2 moles of manganate tetraoxomanganate 7 ion plus 16 moles, 2 times 8 is 16, 16 moles of hydrogen ion plus 10 electrons to give us 2 moles of manganese 2 ion plus 8 moles of water. Okay. Alright. Now we can cross out the electrons. The electrons are gonna go. Now we can combine them. Okay, let's combine them. So let's combine them. And once we combine them, the electrons are gone. So we now have 5 moles of chloride ion plus. I want to write this in order. Okay, I want to write it in order. 2 moles of manganate 7 ion plus 16 moles of hydrogen ion plus 5 moles of water to give us 5 moles of oxochlorate 1 acid plus 2 moles of manganese 2 ion plus 5 moles of hydrogen ion plus 8 moles of water. Okay? See that? Now, by now you know who moves where. You already know that. Okay, so I don't have to write it again. You know that 5 will come over here. 16 minus 5 will give us 11. 5 moles of water, like 5 moles of hydrogen ion will go over here. 16 minus 5 will give us 11 moles of hydrogen ion. And then 5 moles of water will go over here. The bigger guy stays, smaller guy goes. Okay? Bigger guy stays, smaller guys comes. You know, the bigger guys does not go anywhere. If you're big and firm, you don't move, right? Okay. The smaller guys come to you, right? Okay. Well, in this case. So 5 moles of water will come over here, and 8 minus 5 will give us 3. So you already know what it is. So we can, I want us to do at least one more. I know the video is getting long. So our answer will now be 5 moles of chloride ion plus 2 moles of tetraoxo manganese 7 ion plus 11 moles of hydrogen ion to give us 5 moles of oxochlorate 1 acid plus 2 moles of manganese 2 ion plus 8 minus 5, 3 moles of water. And this is acidic solution, so you stop here. This is our answer. Okay? Now let's go ahead and check. Let's check our work. I hope this is making sense, right? I hope this is making sense to you. All right, left hand side we have chlorine, we have manganese, we have oxygen, we have hydrogen. So the same thing here, chlorine, manganese, oxygen, hydrogen. Chlorine is 5 here, 5. Chlorine here is 5, thank God. Manganese is 2 there in the reactant. Manganese here is 2, thank God. Not the charges, the moles, okay, the amount. Oxygen is 2 times 4. 2 times 4 here is 8. 8 in the reactant. And oxygen here is 5 plus 3. 5 there plus 3. And that is 8. Thank God. Hydrogen is 11. 11 there. Hydrogen here is 5 plus 2 times 3 is 6, which is 11. Yes, thank God, yes. Okay, folks, let's do one more, okay? And we can call it a night, we can call it a day, and then you can watch out for part 2, okay? Let's do one more on basic, and then we call it a day, okay? Question 10. Question 10. So we check off this. I have a lot of questions here. A lot. Okay. And we are just doing this, you know, simple ones. You know, later you see ones that, I mean, they're all easy, but, you know, I'm trying to, let's start from the simple ones and then we go to it. Here we have zinc, solid zinc, combining with trioxynitrate 5 aqueous to give us zinc 2 ion aqueous and ammonia gas. And this is in basic solution. In basic solution. All right, folks. So, first thing, we write the oxidation half reaction and the reduction half reaction. Oxidation, reduction. From zinc 0 to zinc 2, that tells you it's oxidation. So zinc is oxidized from 0 to plus 2. The half reaction is from zinc to zinc 2. I noticed I didn't write the state. Did I? I don't know if I wrote the state for the one we just did. You can just look at this website to say it, okay? Like everything I'm teaching you right now is on this website. It's there, so you can see it. All right, then the reduction. This is trioxynitrate 5. Trioxynitrate 5, and this is ammonia gas. Nitride of hydrogen, X plus 3 equal to 0. So this is from nitrogen, trioxynitrate 5, from plus 5 to X plus 3 equal to 0, X equal to minus 3 for ammonia. Okay? So nitrogen is reduced, and the half reaction is trioxynitrate 5 to ammonia. Alright. Balance all elements besides oxygen and hydrogen. Here, oxidation, we have only zinc. We will not bother ourselves at all. For oxygen or for hydrogen, we will not bother ourselves at all. We concentrate now on this. So, balance nitrogen. Balance all elements besides oxygen and hydrogen. So nitrogen is balanced. We're good. Then balance oxygen. So this is 3 atoms of oxygen. So let's add 3 molecules of water here. So this will give us this trioxynitrate 5 to give us ammonia plus 3 molecules of water. So nitrogen is balanced, oxygen is balanced. Now balance hydrogen. Balance hydrogen. So there is no hydrogen here. Yeah, you balance oxygen by adding water. You balance hydrogen by adding hydrogen ions. There is no hydrogen here. There is 3 atoms of hydrogen here and 6 atoms of hydrogen here. Okay, so 3 plus 6 is 9. 3 plus 6, because this 2 times 3 is 6, plus 3, 9. So you add 9 atoms of hydrogen ion here. Okay? And this gives us ammonia plus 3 moles of water. Okay. Nitrogen is balanced, oxygen is balanced, hydrogen is balanced. Alright. Now balance the charges. Let's balance the charges. Here, we need to add 2 electrons here because this is 0. So this will be zinc to give us zinc 2 plus 2 electrons. This is balanced. This is the balanced oxidation half reaction. It's not the whole reaction, no. Just the oxidation half reaction. The reduction half reaction, this is minus 1. This is minus 1. This is plus 9. right? Minus 1 plus 9. This is 0, this is 0. So, minus 1 plus 9, because this is 9 times 1, 9. 9 minus 1 plus 9 is 8. So we need to add 8 electrons. So it will give us 0. So this will be trioxynitrate 5 plus 9 hydrogen ions plus 8 electrons to give us ammonia plus 3 moles of water. This is the balanced half reaction, balanced reduction half reaction. Okay, we need to combine both of them. And for combining both of them, the electrons have to be the same. This is 2 electrons in the product. This is 8 electrons in the reactant. So electron in the product, electron in the reactant. Great, bueno, good. But we need to have the same electrons. So we need to multiply this by 4. We need to multiply this by 4. And when we do that, we have 4 moles of zinc to give us 4 moles of zinc 2 ion plus 8 electrons. Now we can combine both of them. We can now combine both of them. So we have 4 moles of zinc plus trioxynitrate 5 ion, okay, plus 9 moles of hydrogen ion. The electrons are gone. To give us now 4 moles of zinc 2 ion plus 1 mole of ammonia plus 3 moles of water. Okay. Right? If this was acidic solution, we're good. But this is basic solution. So in this case, you see that the hydrogen ion is in the reactants. So we have 9 moles of hydrogen ions. So we need to add, because this is basic solution, we need to add 9 moles of hydroxide ions to both sides. We need to add 9 moles of hydroxide ions to the reactants and to the products. We need to do that because this is the basic solution. So this gives us 4 moles of zinc plus trioxynitrate 5 ion plus 9 moles of hydrogen ions plus 9 moles of hydroxide ions to give us 4 moles of zinc 2 ion plus 1 mole of ammonia plus 3 moles of water plus 9 moles of hydroxide ions. Okay? Then we now combine the hydrogen ion and the hydroxide ion to the water. So this gives us here 4 moles of zinc plus 1 mole of trioxynitrate 5 ion plus 9 moles of water, okay, to give us 4 moles of zinc 2 ion plus 1 mole of ammonia plus 3 moles of water plus 9 moles of hydroxide ion. Then the big guy, the water is here. So 3 moles comes over here. Okay. 9 minus, the big guy stays, the small guy goes. So 9 minus 3 will give us 6. 9 minus 3 gives us 6. So we now have 4 moles of zinc plus 1 mole of trioxonitrate 5 ion plus 6 moles of water, right? To give us 4 moles of zinc 2 plus 1 mole of ammonia plus 9 moles of hydroxide ion. And folks, this is a balanced reaction. Do we stop here? No, not now. We have to do what? Check our work. So let's check. We have zinc, we have nitrogen, we have oxygen, we have hydrogen. In just that order: zinc, nitrogen, oxygen, hydrogen. The same thing here in the products. We have zinc, we have nitrogen, we have oxygen, we have hydrogen. So zinc here is 4. Zinc here is 4. Thank God. Nitrogen is 1. 1 here, 1. Nitrogen here is 1. Thank God. Oxygen here is 3 plus 6, which is 9. 3 plus 6, which is 9. Oxygen here is 9. Thank God, it's balanced. Hydrogen is 12. Hydrogen here is 3 plus 9, which is 12. Thank God. Gracias el Señor. Otito diri Chukwu, ekele diri Chineke na. Chineke na. Chineke na. Ekele diri Chukwu. Okay, folks, we have to stop here for today. Okay, watch out for more videos. If you have any questions, please feel free to ask. And you have a great day.